let's talk about this Wiggers diagram. The Wiggers diagram, there's lots of movement. You see lots of heart sounds. It has volume and pressure and lines and letters and numbers, and it just looks like a lot, but it's a lot more simple than you think. So let's say we have a heart. The heart depolarizes, it contracts, the pressure changes, they're all related to each other, and it can be seen as cause and effect events. Depolarization will start with, can be seen in this ECG tracing right here. This bottom line that has the regular QRS complex that we see. Depolarization is the idea and the process of making the heart less negative. So if we have a heart here that has lots of negative signals going on, when the SA node fires and triggers this, all of these become slightly more positive. And so for the sake of this diagram, we're going to change these to positive. And this happens in sequence as it goes down the heart. Once the threshold of a certain millivoltage is reached, the heart contracts. So when we say contract, it means the heart pushes in here and here on these two bottom ventricles. And when this happens, this is going to push the blood out of the heart. It works like a miracle. There's different forces placed here, in which we'll go into the forces. And to do that, we're going to have to draw a less pretty heart. So let's now draw our heart like a potato, a sea cucumber, whatever you'd like to draw it as. Here's the aorta, and this is where most of the blood will shunt out of very quickly. And then we have two ventricles up here, two atria up here, and two ventricles down here. And this also happens in a sequence. So first, the atria are going to depolarize. And when we said depolarize, we meant get more positive, right? More positive or less negative, however you'd like to say it. And it goes in sequence down the atria first. And the atria squeeze in. So when the atria squeeze in, the blood is allowed to go into the ventricles. These little flaps in between here get to open. And then this continues, there's a slight pause, and then it continues to go down and down. And this happens through the Purkinje fibers, and it actually wraps up that way. This is the signal traveling to make it less negative. This, again, places a force on the blood, because force is pressure exerted, pushes the blood somewhere else. So it pushes in the ventricles and shunts the blood out through the atria. And that's how it gets to the rest of your body. Force on a liquid within a contained system, such as the heart, creates pressure. And now if we're looking at pressure, we'll go back to the Wiggers diagram real fast. Pressure is this top portion up here, and it's got lots of confusing things going on, but really it's just talking about how much pressure is in each portion of the heart during a contraction and relaxation phases. And the pressure can cause valves to open and valves to close. It creates gradients. So gradients go from, the gradients flow in the direction of the blood flow and opening and closing of the valves. And for example, on the Wiggers diagram, where the QRS complex is located, it represents depolarization that causes the heart to contract. The effects of contraction can next be seen on the aortic and ventricular pressure, and this causes the aortic valve to open. So we can see this here, where it's closing, then we have the aortic valve closes, but when we're looking at it opening, it lines up with the QRS because the pressure becomes too great, like a door. So let's draw a valve kind of close up. If we have a door and you have one person pushing on this side and one person pushing on this side, if this person pushes harder than this person, then the door is going to go in favor of this person and push open that way. But if they're pushing at the same force, then it might not move at all. So this is happening here in the Wiggers diagram. We see that the pressure exceeds the flap, and the flap then opens. This causes the aortic valve to open, like I said, and then because the pressure in the ventricle exceeds the pressure in the aorta, the valve opens. The effects of pressure can also be seen on the rapid ejection phase. So we'll go to where the rapid ejection phase is, and that's right here where you can see the ejection. Because the pressure gradient is created, is pushing blood out to the aorta. So when we go back to we'll go to our nice heart. The pressure that's created down here in the ventricles, it gets so much that it's pushed out through the aorta and gets to the rest of our body. So this kind of explains the Wiggers diagram just in a more simple layman's terms, that it's not as complicated as it looks. It's all labeled and it's all related.